From the earliest times, humans looked to the skies with wonder. We watched birds soar effortlessly and dreamed of joining them. Myths and legends about flight filled our stories. Ancient civilizations told tales of flying carpets and winged gods. People tried to turn these dreams into reality. In 15th century Europe, inventors designed elaborate flying machines. These early attempts, though often unsuccessful, showed our persistent fascination with flight. They kept the dream of flight alive and inspired future generations. Leonardo da Vinci, the famous Renaissance artist and inventor, was also fascinated by flight. He studied the anatomy of birds, he sketched their wings and observed their movements. He believed that humans could also fly if they understood the principles of flight. Leonardo filled notebooks with detailed drawings and ideas for flying machines. One of his most famous designs was the ornithopter. This machine had large wings that were intended to flap like a bird's. Another design was his aerial screw. This machine resembled a modern-day helicopter. While Leonardo da Vinci's designs were never built during his lifetime, they demonstrated a remarkable understanding of aerodynamics and engineering principles. His meticulous studies and innovative ideas would later inspire future generations of inventors and engineers. He provided a crucial link between dreams of flight and the scientific pursuit of making it a reality. Leonardo's notebooks remained hidden for centuries. When they were finally rediscovered, people were amazed by his genius. His work showed that he was centuries ahead of his time. He is now considered one of the most important figures in the history of aviation. In the 18th and 19th centuries, inventors moved closer to achieving powered flight. Sir George Cayley, an English engineer, is often called the father of aeronautics. He built and flew the first successful gliders. His gliders had fixed wings and a tail. They looked much more like modern airplanes than previous designs. Cayley also identified the four forces of flight: lift, drag, thrust, and weight. He understood that for an aircraft to fly successfully, these forces needed to be in balance. He built model gliders and even a full-size glider that carried his coachman as a passenger in a short, uncontrolled flight. Other inventors experimented with kites. Kites helped them learn about aerodynamics and control. In the late 19th century, Otto Lilienthal, a German engineer, made over 2,000 successful glider flights. He carefully documented his observations and made significant contributions to our understanding of flight control. His work paved the way for the Wright brothers' groundbreaking achievements. Orville and Wilbur Wright, two brothers from Ohio, made history in 1903. They made the first successful flights in a heavier-than-air powered aircraft. The Wright brothers were meticulous engineers and inventors. They built bicycles for a living, which gave them experience with mechanics and lightweight construction. They built their own wind tunnel to test different wing designs. They understood the importance of control. They developed a system for controlling their aircraft using movable surfaces on the wings and tail. This gave the pilot the ability to steer and maintain stability during flight. On December 17, 1903, Orville Wright made the first successful flight. The flight lasted only 12 seconds and covered 120 feet, but it changed the world forever. The Wright brothers continued to improve their designs. They made longer and higher flights. They inspired others to take to the skies. The age of aviation had begun. Section 5. Wings of War Aviation takes flight in World War I. The outbreak of World War I in 1914 had a profound impact on the development of airplanes. Countries quickly realized the military potential of aircraft. Governments poured resources into developing new and improved airplanes. This led to rapid advancements in aircraft technology. At the start of the war, airplanes were primarily used for reconnaissance. Pilots would fly over enemy lines and gather information. As the war progressed, airplanes were adapted for new roles. They were fitted with machine guns and bombs. Dogfights or aerial battles became a common sight in the skies above Europe. The demands of war led to significant improvements in engine design, aerodynamics, and aircraft construction. By the war's end, airplanes had evolved from fragile wood and fabric biplanes to faster, more durable, and heavily armed war machines. These advancements laid the foundation for the future of military aviation. Section 6, Between the Wars, Innovation Soars to New Heights. The period between World War I and World War II saw remarkable progress in aviation. The development of new technologies and materials led to more reliable, faster, and more efficient aircraft. Metal construction replaced wood, and more powerful engines enabled planes to fly higher and farther. One of the most significant developments was the invention of the radial engine. Radial engines were more powerful and reliable than the rotary engines used in World War I. They also allowed for the development of larger aircraft. This era also saw the rise of commercial aviation. In 1919, the first scheduled passenger airline service was launched in Europe. Passengers were initially hesitant to fly, but as safety and reliability improved, air travel became increasingly popular. The world was shrinking as airplanes began to connect distant cities and countries. Section 7. A Second World War. The skies ignite with technological advancements. World War II once again accelerated the pace of aviation development. The conflict witnessed a global arms race in the air, leading to unprecedented advancements in aircraft technology. The war spurred the development of jet engines, radar, pressurized cabins, and other innovations that would shape the future of aviation. The jet engine, developed independently in Germany and Britain, revolutionized air travel. Jet engines offered significantly greater speed and power compared to propeller-driven aircraft. The Messerschmitt May 262, the first operational jet fighter, took to the skies in 1944, showcasing the potential of jet-powered aircraft. The war also saw the widespread use of radar, which allowed for the detection and tracking of aircraft, transforming aerial warfare. The development of long-range bombers, such as the American B-17 Flying Fortress and the British Avro Lancaster, enabled strategic bombing campaigns that targeted enemy industrial centers and infrastructure. Section 8. The Jet Age, a revolution in speed and altitude. The jet engine revolutionized air travel in the post-war era. The world entered the jet age marked by faster speeds, higher altitudes, and longer distances. Jet aircraft shrank the world, connecting continents in hours rather than days. Air travel became more accessible to the public, transforming it from a luxury into a common mode of transportation. The de Havilland Comet, a British airliner, became the first commercial jet airliner in 1952. However, early jet aircraft faced challenges with structural integrity, leading to several high-profile accidents. Engineers and designers learned from these early setbacks, developing stronger materials and implementing stricter safety regulations. The Soviet Union's launch of Sputnik 1, the first artificial satellite in 1957, further fueled the space race and pushed the boundaries of aviation technology. The United States responded with the establishment of NASA in 1958, sparking a period of intense research and development in aerospace engineering. Section 9. The rise of commercial aviation, connecting the world. As jet technology matured, commercial aviation experienced a golden age. Airlines invested in larger, more efficient, and more comfortable aircraft to meet the growing demand for air travel. Air travel became increasingly affordable, making it accessible to a wider population. The Boeing 707, introduced in 1958, became a symbol of the jet age. It was a commercially successful jet airliner, capable of carrying a large number of passengers over long distances. Other iconic jetliners, such as the Boeing 747 Jumbo Jet and the McDonnell Douglas DC-10, followed, further expanding the reach and capacity of air travel. Airports grew in size and complexity to accommodate the increasing volume of air traffic. Air traffic control systems became more sophisticated to manage the flow of aircraft safely and efficiently. The rise of commercial aviation had a profound impact on global tourism, trade, and cultural exchange, shrinking the world and connecting people across continents. Section 10. The future of flight, supersonic dreams and beyond. The quest for faster and more efficient air travel drives innovation in aviation. Researchers are exploring new technologies to push the boundaries of flight. Supersonic aircraft promise significantly reduced travel times. The Concorde demonstrated the feasibility of supersonic passenger travel. However, high operating costs and limited capacity pose challenges. Researchers are now investigating hypersonic aircraft capable of exceeding Mach 5. These could enable travel between any 2 points on Earth in a few hours. The quest for flight continues, promising faster, more efficient and sustainable ways to explore our world.